All right, well, hello, Course 1, 2, and 3. It is that time again for another fun-filled, exciting lesson with Mrs. Brua. Hopefully you've downloaded the slides, and in a split screen, you have this video playing. Remember, I'm going to go through the slides. I'll put everything down, write everything down. You should do the same on yours. If you need to pause the video so that you can do a little bit of learning, catch up, rewind, whatever, make sure you're doing that as we go through the slides. And hopefully at the end of this, you will be feeling good about your journey with boundary points and writing what the boundary point is with the inequality. So that's kind of our goal. Let's get started. All right, so over the last couple of days, you've explored finding the boundary point on a number line and then graphing that boundary point on the number line. You've talked about what it means to have a circle that is either open, like this, or a circle that would be filled in. When you have the circle that is filled in, that means that you have also equal, or actually equal. When you have the circle that is open, you have just greater than or less than. I think most of you got that. I think you've had a lot of practice, and I have taken a look at everything you've sent in. I have given you some notes if there's anything you need to take a look at, but I think overall you guys have done an amazing job, and I'm super proud of you. So a couple of the problems from yesterday actually had a negative exponent and a rule that was kind of confusing. I apologize about that. Kind of wanted to see where you guys would go, and I didn't prep you well. I know that Mr. Gribble came in and gave some information on that. We're going to just put that to the side right now, and we'll talk about it later when I come in. We will get to it, but it's not going to be relative to what we're doing over the next couple of days. So I appreciate your hard work, but today we are going to move forward in our learning journey. So of course, as usual, I like to do a warm-up, get those brains moving. So this should be old learning for you now, old stuff. The question on the top says, to find the boundary point and represent it on the number line below. So just to make sure that you are using best practice as you go through all of your math journey throughout the year, we will start with saying what the boundary point is. I'm going to just write BP for boundary point, so it's just kind of easier and faster. The boundary point here would be found at -3. What you need to do is set up your number line right here so that -3 kind of lies, somewhere so that you can show the extension of where the inequality is on either side of -3. So for this inequality, I'm going to want to set up the number line so that my -3 has numbers after it. So I'm going to push my 0 to here. And then I'll fill in my positive values moving forward. You can always look up at that number line right in the front of the classroom if you forget. On the other side of 0 would be our negatives, -1 and -2, -3 and -4, -5, -6, and then -7. We know that our boundary point is going to exist at x is equal to and greater than and equal to -3. So we're going to draw ourselves a circle over the boundary point, which we determined earlier is going to be -3. We're going to fill that boundary point in because there is also equal to. So I'm going to fill that in right now. We want that circle nice and filled in. And then we're going to draw our line. Now, our line is going to be extending from -3 to values that are greater than that. So we're going to take our line and we're going to come away from that. And we're going to put an arrow at the end. A lot of you are forgetting the arrow. Please do not forget the arrow. It is super important because otherwise it is just a line segment and not a line that continues on forever. And these are inequalities. All right, so that's the first one. Let's go ahead and work on our second one. So again, we want to name what that boundary point is. Our boundary point here is at 5. So let's go ahead and start to set up our number line. I think I will put my 5 kind of over here. I think I'll do 5 right here, and then 6 and 7 and 8. And then I'm just going to go backwards and see where it ends up. 1 and then 0, -1, and -2. All right, so that worked out pretty well. Let's go ahead and put a circle over top of our 5. Now, do we want to fill this in? No, we do not, because this is not also equal. There's no little line underneath that. So we're not going to fill it in. We're just going to draw our line away from the circle. So again, this is values that are less than 5. So we're going to come this way. And again, we're going to draw ourselves a nice defined arrow so that I know that you know that this is a line, not a line segment, and it's going in that direction. All right, let's keep going. Of course, it's important to go backwards too, right? So we're going to write the inequality for this situation. Where do we start? We start by naming what our boundary point is, right? Our boundary point exists right here. It is 1. What we've talked about is we have x on the left and the boundary point on the right. Let me fix that. It's kind of messy. All right. We are talking about values that go this way, right? So that's what our arrow is going to look like. And do we have it filled in? No, it's open. So that's it. No line underneath it. And there we go. That's everything you've done for the last 2 days. And again, you've done an extraordinary job with this, and I'm super proud of you. So today we're going to continue to graph some stuff, not as much on a number line, but first we're going to need to solve the equations for a single value of x. So that's going to be the addition of our learning today. We're going to be adding some layers as we go on. So as you work through today's lesson, I would like you to keep in mind the questions below. These are our learning targets that come right from our textbook. The first one is, what is a possible solution to this situation? Thinking about that will help you move forward and find what the actual solution is. Next up, what do all of our solutions have in common? Well, the answer to that is going to be that they are all inequalities. And then lastly, what's the greatest and what's the smallest solution? So those questions right here, this last one, is what you use to frame the idea of which way does my line go away from that boundary point, to the left or to the right, greater than or less than, and is it filled in? So that's kind of where we're headed. All right, let's get started. Before we get into the actual problems, there's a couple of things that we need to remind ourselves of, and we talked about these last week when I was in school. So I wrote here, let's get something straight before we begin. X is kind of a big deal. Remember? X wants to be all alone in the spotlight. It likes to be front and center. So we have some algebra rules that help us get X all by itself. They were make 0 pairs and combine like terms. So we did that on our maths. Today we're not going to have our maths. We're just going to have some expressions, some inequalities, and we're going to see if we can make some 0 pairs, combine like terms, and see where that takes us. So here we go. So far in this class, you've been able to see, and I put that in quotes, the boundary point when you looked at the inequality. For example, the boundary point in the inequality, x is greater than 3, would be 3. It's pretty obvious, right? There's a single value for x. It's all by itself, and it says that it's bigger than 3. Fabulous. But not all of the inequalities that we're going to use are set up so straightforward. So when you look at the boundary, or you look at the inequality below, what do you think the boundary point would be for it? 3 plus x is less than 3. So hopefully what you're thinking of is, well, what if x is 0? And what if x is 1? And what if x is -1? And you're using that idea that we used a couple of days ago, last week Thursday, to kind of check ourselves to figure out where that boundary point exists, where the change in the inequality exists, such that this inequality becomes true or false. That's what our boundary point is. It's that point where it no longer is true and it becomes false. So when our variable, in this case our variable is x, and hopefully you know that from your R&P on Monday, is with other values, it's harder to just see what the boundary point is, right? So in these cases, we're going to need to do something called solving. We're going to solve for the boundary point, and that's what we're going to talk about today in our class. So how exactly do we solve for this boundary point? Well, we want to think of getting x alone, remember? X is a big deal. We also want to remember all of the rules of algebra and everything that we've talked about from the very beginning of school until this point right now. And those things right now are, remember, every number has an opposite value. What's the opposite value of 2? It's negative 2. What's the opposite value of negative 10? It's positive 10. So obviously we've talked about that a lot. You need to know that information moving forward. Number 2, when you add opposite values, you get 0. That's kind of the whole point, right? We're trying to make those zeros. We're trying to get x alone. So we're trying to make 0. And the last one, and we talked about this a lot in class, is you must do the same thing to both sides. So remember that when I was standing up in front of you and I was pretending like I had things in my hands and they were at the same level, and if you took one away, I was kind of tilted over, but we always wanted to be balanced. So the biggest thing about algebra, of course, is creating and finding and maintaining the balance that's necessary so that you can continue to solve equations. All right, so let's talk about what we're going to do. So the first thing I want us to think about is we're going to draw the line right down from that inequality because that's creating the balance that we need. And we're looking at two sides. We have a side here and we have a side here. We are trying on this side right here, because that side has the x, to get everything away from x. Well, what is with x? With x is 3. And rule number 1 says every number has an opposite value. When you add opposite values, you get 0. Well, we want to get that 3 away from the x because x is a big deal, right? It wants to be by itself. So what is the opposite of 3? Well, the opposite of 3 is negative 3. So we are going to add a negative 3 on this side. Well, rule number 3 says you can do whatever you want on one side of our line, but you have to do it on the other. So if we did negative 3 on the left, we're going to go ahead and do negative 3 on the right. All right, so we're going to draw ourselves a line, and we're adding, right? Well, negative 3 plus 3, that is a 0 pair, right? That creates a 0 right there. So what do we have left? On the left, we have x left on the left. And that's going to be less than. And then what ends up happening on the right? Well, unfortunately, we also end up with a 0 pair on the right because 3 minus 3 is also 0. So we end up with x is less than 0. Okay, so our boundary point is 0. So let's go ahead and we're going to make our number line. I'm just going to put 0 right here in the middle. And I'll just put a couple of values on each side just so that I can show you. Next up, I'm going to draw myself a circle right up above 0. And I'm not filling it in, right, because there's no equals to. But I'm talking about values of x that are less than 0. So I'm coming way over this way. And I'm going to make myself a nice defined arrow. That is the way that we prove the value for the boundary point of 0 for 3 plus x is less than 3. So that probably feels pretty confusing. If you want to pause the video, look at it again, you go right ahead. We're going to do several more examples. When you're ready, move to the next slide. All right, welcome to the next slide. We're going to try another problem. We're going to do it exactly like we did it the last time. The first thing we're going to do is we're going to draw ourselves a nice line right down from that inequality. Now we've created a balance point. Again, we want to get everything away from x on this side. So what's with x right now? This -5. Well, what's the opposite of -5? +5. So we're going to add 5. Remember the rule, whatever you do on this side, you must do on this side too. So if we add 5 on the left, we are going to be adding 5 on the right. Let's draw ourselves a line. We're adding. What ends up happening? Well, we created that 0, right? That's excellent, because now when we do that, we end up with just x on the left, and that's going to be greater than, well, 1 and 5 is 6. So no 0 this time. So our boundary point is 6, which is perfect. So I'm going to put 6 right in the middle here. I'm going to change that to be black. I'm going to put that right in the middle here. And then I'm going to add a couple of values on each side. And you can certainly do this. You don't need to start at 0 every time. So what am I talking about here? I'm talking about values of x that are greater than 6. So my boundary point is right here. It is not filled in. And I'm talking about all these values that are bigger than 6 with a nice big defined arrow at the end. Hopefully that felt better. Let's keep moving on. All right, let's do it again. Same process. We're going to draw ourselves a line. Now, we need to ask ourselves, what's with x? Well, this 4 is with x, and we don't want the 4 there, so we're going to go ahead and we're going to add the opposite. The opposite of 4 is -4. And what you do to one side, you must do to the other. So -4 on both sides of the line keeps us in balance. -4 plus 4 ends up being 0. So what's left on the left? X. And that is going to be less than or equal to -4, because 0 plus -4 is -4. So our boundary point, in this case, is -4. So I'm going to go over to my number line. I'm going to put -4 right there in the middle. -3, -2, -5, and -6. Now I'm going to go ahead and I'm going to draw my circle. My circle is right above -4. And yes, you guessed it, this time it is filled in finally, because we finally have equality on the other end of that. Go back up. And what are we talking about? We're talking about values that are less than or equal to -4. So there's my line with my arrow, and we are done. How did that feel? Hopefully that felt pretty good. I think you're probably getting it at this point. If not, go back and watch over those slides one more time. If you do have it, or you've watched them over and you're ready, let's move on. All right, so now that you're a pro, we're going to make it a little bit more challenging. We're going to add one more step. But remember, you do all the other steps, and then you just add the same steps over and over and over again. Where do we start? Well, we always start by putting a line, so let's do that. The next thing we ask ourselves is, what's with x? Well, let's see, this +2 is with x. All right, we need to get rid of that, don't we? So how do we get rid of the +2? Well, we get rid of the +2 by subtracting 2. So let's subtract 2 and subtract 2. All right. When we subtract 2, this ends up being a 0 pair. Perfect. That's exactly what we want. Or is it? 6 minus 2 is going to give us 4, and that is going to be greater than or equal to, 2x. Well, x is not by itself. It doesn't have anything that's adding or subtracting, but it does have this 2 next to it, right here. We don't want that, do we? No, definitely not. What you need to remember, I'm going to just draw kind of a little upside here, is 2x actually means 2 times x. That's what it means. All right, so remember, the first rule was to do the opposite. All right, well, what is the opposite of multiplication? Ding, 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 you are all right. It is division. Right? Okay. So we're going to go back to our rules of algebra. We want to get rid of that 2. Well, that 2 is being multiplied. So to do the opposite, we are going to divide. Remember, I don't know, week 2, I told you fractions are just a really fancy way of doing division. So we're going to make this into a fraction. We're dividing it by 2. We have to do it on both sides, right? That's our rules. Well, 2 divided by 2 is 1. That gives us x. Phew, x is finally by itself. And 4 divided by 2 is 2. Excellent. Well, x is not on the side that we like, so I'm just going to flip it. I'm just going to write x, and we have a little tiny one that way, 2. I'm just going to do it that way, because I like to draw my stuff so that it leads with x on the left. All right, our boundary point is 2. So let's go ahead and see what we've got here. We're going to start with, I guess I'll put 2 in the middle. We'll have 2 and 3 and 4, 1 and 0. Boom. Okay. We're going to make ourselves a circle over top of 2. Not filled in, but we're talking about values that are less than. So there we go with our nice big arrow. And you have just challenged yourself and solved for x by finding 0 pairs and by dividing by the opposite. Well done. Let's do it again. All right, starting in the same place. Make ourselves a line. First thing you want to do is go after whatever is adding or subtracting. Don't know for some reason. There we go. Okay. So let's do that. Plus 5, the opposite of plus 5, that's minus 5. And by now you're an old pro. You know you have to do it on both sides. Okay. We'll make ourselves a little addition sentence. We also know that we've created a nice pretty 0 pair here, which is fabulous. It's exactly what we want. So on the left we have 2x. Oops, that seems like a problem. And then over here we have -2. All right. Well, the opposite of multiplication is in fact division. So we're going to divide each side by 2. 2 divided by 2 is 1. So it's x is less than, and -2 divided by 2 is -1. So our boundary point in this case is -1. Fabulous. That wasn't too awful. So again, I'm going to put -1 right in the middle. That would be 0 and 1. -2 and -3. If you forget, just look up. All right. -1 is an open circle. And again, we're talking about values less than that. And there we go. How'd you do? I bet you did great. Let's keep going. Now that you're a professional inequality solver, let's try some word problems. Dun, dun, dun. Fear in the heart of every math student when their teacher says that. It will be fine. Here we go. Word problems with inequalities. The speed limit on certain freeways is 65 miles an hour. Let x represent any speed that could get a speeding ticket. All right, so we're going to write our inequality. Well, we know we have 2 values, right? We have x and we have 65. So we're going to have x and we're going to have 65. So let's ask ourselves the question. We need to have one of these, right? One of those four. All right. So the speed limit means if you go 65 or less, you're good. If you go greater than 65, 66, 67, 68, you're going to get a speeding ticket if you get caught. But you shouldn't do it because it's dangerous. So X represents any speed that could get a speeding ticket. So we are talking about all speeds that are bigger than 65, but not equal to 65, because 65 won't get you a speeding ticket. So we're talking about all values of X that are bigger than, but not equal to 65. Our boundary point is 65. So now we're going to make ourselves a little number line, and I'm not going to fill the whole thing in because it feels like a lot of numbers. 65, 66, 67. I'm going to just get lazy, and 63. I'm going to make myself a circle. Remember, it is not filled in, and we are talking about all values that are greater than that are going to get us that dreaded speeding ticket. That wasn't too bad, was it? Let's do another. Alrighty. You went to the mall with $10. Doesn't feel like a lot, but these are the examples from the book. What can I tell you? X represents any amount of money that you can spend. Again, we've got two values, 10 and X, so we know we want X on this side. We know we want 10 over here. Well, you can spend anything you want up to and including 10, but not over 10. So that means you're talking about all values less than and equal to 10, because anything bigger than that is going to be a problem. Our boundary point is 10. Again, I'm not going to make all of these numbers on here because I'm just a little lazy. 10 and 11 and 12. We're going to go 9 and 8. Let's go ahead. Make ourselves a nice circle that we are going to fill in, because we're also talking about equals. There we go. And we're talking about all values less than and equal to 10. Obviously, this would have a second boundary point, which would be 0, because you can't spend less than 0. But we can talk about that another day. All right, that, my friends, is your very last slide for the day. That's a lot of learning. I have for you a very short RMP that is in the modules. There's a key and also a link to the turn-in. You can turn it in right from the modules, or you can go to the assignments. It's up to you, whatever you'd like to do. Please make sure you're checking the key before you turn it in. That's not copying as long as you're actually doing the work and checking. If you happen to finish prior to the end of class, I would like you to silently read or work on work from another class. I am excited to see you guys on Friday, and tomorrow will be a pure work day for you. Have a great rest of your day, everybody. Bye-bye.